Hey everyone, this is Rashmi and today I am going to discuss about the next part of the question. Already we have discussed up to the question number 3. So today I will discuss about the questions of the question number 4. So the first question is evaluate. Some limit question is given. So we have to find out the value of the limit. So let us find out the values. So this is the first question. Limit x tends to 0, then root over 1 plus 2x minus root over 1 minus 2x divided by x. Now since here x tends to 0, that means we have to substitute x equal to 0. Now in this question, if we directly substitute x equal to 0, then let's see what values we will get. So it will be 1 into 0, because multiply 0 to any number, the value is always 0. Then minus root over 1 minus 0 divided by 0. So we will get root over 1 minus root over 1 divided by 0. That means 0 by 0. Now in case of function, this is not acceptable. We cannot get a value which is 0 by 0, or you can say that 0 divided by 0 is not acceptable. That's why we cannot directly use the value x tends to 0, that means x equal to 0 here. First of all, we have to remove this term divided by x. First of all, we have to remove this term, then only we can substitute the value x equal to 0. Now how can we remove this term? First of all, if we assume that this value is a value, one value a, this value is b. Okay, first of all we assume that a value is equal to 1 plus 2x, root over 1 plus 2x. Then we assume that b is equal to root over 1 minus 2x. Then what the question will be look like? The question will be look like x tends to 0, a minus b divided by x. Now we will introduce the term a plus b. Okay, since we introduce the term a plus b to the numerator, then we have to also introduce the term to the denominator. Then only after cancellation we will get the actual value. Now this is a formula, a minus b into a plus b. This is one formula, and the value is a square minus b square. So first of all, now we will introduce the term a plus b. So let us write down limit x tends to 0. Already we have the term root over 1 plus 2x minus root over 1 minus 2x. If we assume that this is a minus b, so we have to write down a plus b value. So plus root over 1 minus 2x. Okay, so then now in the denominator we also have to write down this value, plus 2x root over 1 minus 2x. Now since this value is a minus b into a plus b, so by the formula we can write down a square minus b square. Okay, and the denominator is x into root over 1 plus 2x plus root over 1 minus 2x. So it becomes limit x tends to 0. Now this is root over, and after the root over we have this square value. That means we will got the value 1 plus 2x, then minus 1 minus 2x divided by x into root over 1 plus 2x plus root over 1 minus 2x. Okay, now limit x tends to 0. This is 1 plus 2x. There is a minus sign before the bracket value, so it becomes minus 1 plus 2x, and this equal to x root over 1 plus 2x plus root over 1 minus 2x. Now 1 minus 1 will be cancelled out, so limit x tends to 0 divided by 4x. 2x plus 2x equal to 4x, then x into 1 plus 2x plus 1 minus 2x. Now you can see that we can cancel the term x. So after cancellation, the remaining values are 4 divided by root over 1 plus 2x plus root over 1 minus 2x. Now you can see that if you directly substitute the value x equal to 0 here, it will not give you 0 by 0 format or divided by 0 format. So now we can directly use the value x equal to 0 here. So 4 divided by 1 plus 2 into 0 plus root over 1 minus 2 into 0. Okay, now we will get 4 divided by 1 plus 0 plus 1 minus 0. So we can get 4 divided by root 1 plus root 1. Now root 1 value is equal to 1. So 4 divided by 2. So now we get the value which is equal to 2. So the answer of this question, limit x tends to 0 root over 1 plus 2x minus 1 minus 2x divided by x, the answer is equal to 2. Okay, now move on to the next question. The next question, this one, limit x tends to 0, then a minus root over a square minus x square divided by x square. So now let us solve this question. Now see here, again the value x tends to 0. Now if we directly substitute x equal to 0, let's see what values we will get. So a minus a square minus 0 divided by 0. So you can see that we again get the value divided by 0 here. So that's why we cannot directly substitute x equal to 0 here. Again we have to remove the term x square. Now how can we remove the term x square? Here if we assume that this is a minus, this is one value, a minus b like the previous one, then we have to introduce the term a plus b. Then only we will get the value a square minus b square. So now let's get started. Limit x tends to 0. Now the values is a minus root over a square minus x square, then minus a plus root over a square minus x square divided by x square. Since we have introduced this term to the numerator, that's why we have to again introduce the term to the denominator. So it becomes a plus root over a square minus x square. Now limit x tends to 0. Now this is a minus b into a plus b. So here we can write down a square minus b square. So it become a square minus root over a square minus x square whole square divided by x square into a plus root over a square minus x square. Okay, now limit x tends to 0. This is a square minus this is root over and then square. So it becomes a square minus x square, then divided by x square into a plus root over a square minus x square. Okay, now x tends to 0, this is a square. Since there is a minus sign before the values, before the bracket, so if we remove the bracket, so the values become a square, this is minus minus plus x square, and the denominator value is x square into a plus root over a square minus x square. Now you can see that this is a square minus a square, that means we can cancel the values. We can cancel the values, a square minus a square. Now the remaining values are x square divided by x square into a plus root over a square minus x square. And now you can see that there is a x square term and x square term in the both numerator and denominator. So now we can cancel these values. So after cancellation, the values are 1 by a plus root over a square minus x square. Now if you directly substitute x equal to 0 here, then we will not get the value 0 by 0 term or divided by 0 term. That's why now we can directly substitute x equal to 0. So this is 1, then a plus this value is root over a square minus 0 square. So here it becomes 1 plus a plus root over a square. Now this is a square and root over. So this is a plus a into 2 into 1 by 2. So this is a plus a, that means 1 by 2a. So this is the final result. So the question is limit x tends to 0, a minus root over a square minus x square divided by x square, and the solution is 1 by 2a.